Okay, let's welcome to the Power BI session of data visualizations. Now let's continue the session with few more visualization tools. Today first we are going to discuss the waterfall chart model. Waterfall chart, as the name indicates, it normally displays the data in a continuous or series format. So sometimes time series data are denoted in the waterfall model. Now let's see how the waterfall model works. So we have selected the visual, and for an example we can first add category in our category as region, and let's have the y-axis as sum of profit. So you can see now the sum of profits are increasing in the trend. So it's shown in that way as a total. But waterfall models normally can show any kind of trends, that is increasing, decreasing. So to waterfall models show as a running total of Power BI and adds and subtracts the values. These charts are useful for understanding how an initial value like net income is affected by a series of positive and negative changes. So each measure of change is a column on the chart. The columns are color coded so that you can quickly notice increase and decrease across the data. The initial and final value comes often as configured to start from the horizontal axis. The intermediate values are normally floating columns. The initial value we can say east region started, and rest of the values are floating columns. The starting point for an intermediate column can be on the horizontal axis or on the other axis parallel to the main axis. The position of intermediate columns can fluctuate between initial and final values. The resulting view creates a picture that is similar to a concave or convex wave or a random waterfall cascade. So, because of that nature, waterfall charts are also called as bridge charts. So let's see, this is a very easy example and straightforward where there is no decreasing trend. Now let's see another waterfall model where there we can see both the trends. So for that example, I am including subcategory in the category section and break into the breakdown region we can give region, and then the y-axis we can give the same data, that is sum of profit. So let me make this visual pretty small. Now let's see what happens with this visual. As you can see visually itself, the waterfall model denotes both increasing and decreasing trend. We have a lot of subcategories and each subcategory is further divided into region. Certain subcategories come with the increasing trend, certain things comes with a decreasing trend. And blue it is shown the total. So we have, when we have increasing values, it's green in nature. So this is what we say, it is can be either concave or a convex curve. And because of this nature, this is a continuous time series data. The waterfall chart is also known as bridge chart. So it bridges through from the initial to starting values continuously. It's a bridge value. Here we comes to this region, it's actually a concave because all the three regions have a decreasing trend. So when we use a waterfall model, the waterfall charts are a great choice for many scenarios. It normally represents changes for a measure across a time series or different categories. So when an organization wants to see how a particular value is changed across a time period, the waterfall model is a very good option. We can audit the major changes that contribute to total values. Visually, an auditing can be done. Easily, we can identify where the decreases are happening, where the increases are happening, such kind of things. Now, we can actually plot the company's annual profit by showing various sources of revenue and arrive at a total profit or a loss. So we can illustrate the beginning and ending of headcount for your company in a year in the waterfall model. We can visualize how much money you earn and spend in each month and running balance for your account. So that's about the waterfall model. Now let's move on to the next model, which is a funnel shaped model. First, let's remove these visualizations. And next visualization is a funnel model. And funnel model is also, funnel visualization is also very important in terms of business intelligence. Because this, as we explain this, you can understand this. If we represent data in this visualization, um, it denotes the bottlenecks in an organization or how healthy the process in an organization is. So ultimately, the use of data visualization is to find out how good the uh, organization functions. So funnel chart, for the first example, we can see the funnel chart with category as region, and then moving on to values as sum of profit. So it denotes, from looking at this chart itself, we can see east has maximum amount of profit, west is in second category, south is central. No need to explain anything. The picture itself says which region has highest profit, which region has the lowest profit, and how it works. The funnel chart helps to visualize the linear process that has a sequential connected stages. The common use for a funnel chart is that it can track sales and customers through stages, such as we have a lead, a qualified lead, or a prospect, which leads to contract and closing of a sale. So when a customer puts an inquiry, how that inquiry is getting tracked, and finally whether that inquiry leads to a final sale. This kind of process, if we take up the number of leads, number of inquiries, following up, and final sales, we can find that tracking process is how healthy in the organization. Now, each funnel stage represents the percentage in total. In most cases, funnel chart is shaped like a funnel where the first stage is the largest and the subsequent stage is smaller than its predecessor. A pear-shaped funnel shape is also useful that can identify the problem in the process. Typically, first stage called the intake stage is the largest. Funnel chart help support many capabilities such as sorting and displaying multiples. You can highlight and cross-filter data in funnel chart by selecting data on the other visualizations on the same report page and vice versa. Now, let's see the funnel charts in detail. This is a very pretty simple chart. To have another, let's have another funnel chart which has large amount of data, and let's identify what we can learn from that particular data. So select another visualization as a funnel chart, and for this example I'm going to give category as subcategory, and then the values are again sum of profit, and let's for our easy understanding, let's just change the color of this particular visual. So just changing the colors. Okay, So now what does this particular data means is that if you look into sum of profit by region, it just shows the regions. Now we have subcategories, the item list, copiers, phone, accessories, pager, and shares. If we see, it's arranged decreasing order, but last we have fasteners, and then we have supplies, bookcases, tables. The value itself is a negative value. So looking at the visual itself, we can say suppliers, bookcases, tables all have a negative value. This negative value in itself indicates that they are in loss. So we can actually see how it changes over the east side. Then we select west side the data, and here we can find an interesting thing. Machines, they have a negative sale, or negative profit means it's in loss. But whereas here comes the tables are no, if when we take as a whole, tables are in loss, but in the west region tables are in higher. So using these two funnel sheets, we can actually identify a lot of things, which things gives maximum profit in which category, which region, and those things. And this data is really visually appealing, and from the visuals itself we can understand a lot of information. So let's see, when we use a funnel chart, uh, possibly funnel charts are great choice in many great scenarios. The chart that shows the progress of sequential data through the four, at least it should have four stages. The chart items where the amount of first stage is expected to be greater than the amount in final stage, we can calculate the potential. So in this particular case, actually by calculating the profit, we are calculating the potential of that superstore, so such as revenue, sales, deals, and so on by stages. So these values indicate how good the organization is, so we can actually calculate the potential of the organization. We can calculate and track conversations and retention rates in the organization. We can reveal the bottlenecks in the linear process. That is very important aspect of funnel charts. We can track workflow of a shopping cart, track the progress and success of clicking through advertisements, marketing campaigns. These are two examples, and I would like to explain little more about the bottlenecks, how funnel charts can indicate bottlenecks. For that, I have another example. This is actually a funnel chart created on another data, basically. So we have this dashboard. If you can see, this is a funnel chart, but it doesn't provide the funnel shape. Why it doesn't provide the funnel shape? Because the unit purchased and units sold and stock units are not uh, following the business acumen, because this particular organization purchases 9090 units, but they are selling only 32 units. So their stock is very high still, because their business is not performing. The sale is happening only on some around 3%. So looking at this thing, we can easily see there is a bottleneck at the sales stage of this particular organization. So if your organization have bottlenecks in a particular data, just plotting that data into a funnel chart can visually can easily give you the bottlenecks that's happening in the organization. That is why we are saying the funnel charts can indicate the potential or the health of business processes in an organization. So that's about the funnel charts. Now let's move on to the next chart, which is scatter diagrams. Okay. The most important aspect about the scatter, before we enter, the scatter diagrams in Power BI visualization, scatter diagrams provide a lot of data points to be plotted compared to all other graphs, bar graphs, pie charts, waterfall, everything, line graphs, and everything. See how actually the data point limit for a scatter chart is 10,000. So let's see scatter diagrams in detail. So first let's see an example. We can add segment in the values over here. So there are three segments: consumer, corporate, and in the x-axis, let's see, we can give sum of quantity, number of items we sold, and in the y-axis, let's give the profit. So the profit with the quantity is plotted, and there are only 3 points available over here. So but three data points available. To learn about the scatters, let's just simply increase. If we hover over these data points, actually segment consumer sum of quantity is 9,686, and the profit amount is given. So this is our next segment, corporate, and this one is um, home office. Now I'd like to expand this sum of segments into regions. So we have 4 regions, and if we expand it through legends, we have 12 data points. Since our points are very small, now let's format our visual. In the markers, we can actually change the shape, size, and everything. Now let's change the shape into a rectangle, and we can just increase the size. Okay, now our scatter diagram is, so here there are only 12 data points, whereas actually we can have 10,000 data points in a scatter diagram. Now let's see what are the properties of scatter diagram. The scatter charts normally display the data along with the horizontal x and vertical y axis. The chart reveals how numerical values along the two axes are related. When data intersects on two axes, Power BI displays a data point. You can analyze data points to identify relationships in your data. So the data points are distributed evenly or unevenly across the horizontal axis depending on the chart data. You can set the number of data points up to a maximum of 10,000. Then we have tooltips are available on all data points, and the tooltips, that this is the tooltip value. You can see the tooltip, the value, segment, region where sum of quantity, and everything is actually readily available. So tooltip shows the details of the data based on which the data is represented in the charts. So the scattered diagram visuals help to reveal the relationships and patterns in your data. The chart visualizations can actually identify increasing information about your data that might not be readily apparent by just looking at the numerical values. So these scatter diagrams are really useful for comparing large amounts of data points without any regard to any specific time. The more the data you include, the better comparisons you can actually make. And what are the situations in which we make the scatter diagrams? Scatter diagrams work well in many scenarios. It normally shows the relationship between two numerical values. It plots the two groups of numbers as one series of x and y coordinates. It displays the worksheet data with pairs or group sets of values. It shows patterns in large sets of data. It compares a large amounts of data points irrespective of time measurements. It can convert a horizontal axis into a logarithmic scale. It can substitute for line charts to enable changing horizontal axis. So line charts are really good examples to show the data. But the scatter diagrams can actually create more data and more information compared to line charts. Now let's see the next visualization, which is next are two visualizations that are pie charts and donut charts. Both are actually very similar in nature. So let's have a detailed explanation on pie charts, because the data points and the criteria for pie charts are, there are certain criteria we need to consider when we create a pie chart. As you can see, pie charts are very common in dashboards, and from pie charts we can infer a lot of information. Now first let's create a very simple pie chart. First, it includes the legend as a segment. We have three segments and sum of quantity as a value set. So these are the three legends, and we can actually modify the colors, everything over here. So slices, we have these colors, and just um, for the sake of this, let's change the color. Let's keep it this way. So these are the this is our pie chart. Now one thing we have to identify in the pie chart is we can actually increase the information in the pie chart. So let's format the visual. We can add more data. So I can add regions into this. So I already have three segments. It is further divided through using these white lines. It is further divided into four. So total of 12 segments and information is given. So our data is increased, and if we cut the regions, and if we add subcategory, there are numerous subdivisions. So how much data give, the pie charts will simply represent it by cutting or slicing the uh, round. Actually, you can see we normally say the circle have numerous divisions depending on the its diameter. It's an infinite shape on it, so it doesn't matter. But this is not visually appealing. This is too much information and data. So let's see, creation of pie charts is just we need to select the data and add it. There is much to it, but how we select, what are the criteria for selecting an information for being pie chart, that is the most important aspect in uh, pie charts. Pie charts and donut charts display data as a proportion of a whole in a report. Pie charts are most commonly used to make comparisons between groups. Pie and donut charts, along with the pyramid funnel charts, we call it as shape charts, because the most important aspect of this chart is the shape. When a numeric field is dropped into a shape chart, the chart calculates the percentage of each value to the total. So all the shape charts have this aspect that we are actually putting a numerical value into a shape. So let's see what are the data considerations for pie charts. Pie charts are popular in reports because of their visual impact. The pie charts are easily understood by any person. However, pie charts are very simplified chart type that may not best represent your data. Why it is? We need to have a pie chart only when you can aggregate our data points into 7 or less. So that's why I have shown you an example of this adding the subcategory into details. See, chart will be created, but it is not visually impacting and it's very difficult to obtain the data from it. So what is the standard is that only when our divisions are less than 7 or less than 7, we create a pie chart. Pie charts display each data group as a separate slice on the chart, so we must at least add one data field and one category field to the pie chart. That's a minimum criteria for the pie chart to show. If more than one data field is added to a pie chart, chart will display both the data fields in the same chart. It don't create another pie chart, it just subdivides the same pie chart. And the pie chart itself aggregates the data points that's given. Because of that, null, empty, negative, and zero values have no effect when calculating ratios. For this reason, these values are not shown on the pie chart. If you want to visually indicate these types of values on your chart, change the chart type to be something other than the pie chart. If you are defining your own colors on the pie chart using custom palette, make sure you have enough colors and display each data points with its own unique color. Now you have, unlike most of the charts, pie charts will display individual data points, not as individual series. It's in legend. The pie charts require at least two variables in order to make a valid comparison between the proportions. If your pie chart contains only one color, verify that you have added a category field to the group. When the pie chart does not contain categories, it aggregates the values from your data field into one value for display. Like other chart types, the pie chart generates colors based on the color contained in different palettes. So we can actually change this. If we have multiple pie charts, we need to change the colors. Then only it will be manually possible to identify the things. And now comes to the donut chart. It has nothing, just the simple shape is that every other criteria are same for donut chart. So the same data we can just select the donut chart and data will be displayed in a different shape. So that's for this session. We can see the rest of the data visualizations in another session. Thank you.